Okay, so moving on to example number 2, the instruction is the same. Sketch the graph of the function and determine its domain, vertical asymptote, horizontal asymptote, range, x and y intercepts, the key points, and if there are any holes. Still, we're not going to see cases with holes. That's for the next video. So, the given function is f of x is equal to 3 over 2x minus 8. And I have to sketch the graph of this one and determine all of its elements. Remember, it's always convenient to check if I can factor and cancel out. If I can't cancel out anything, there are no holes. So, step number 1. The first thing that I do is determine the domain and the vertical asymptote. So, in order to determine these ones that are VA is now the vertical asymptote, it's just abbreviation. I have to solve for x at the denominator of the function. So the denominator is 2x minus 8. It cannot be equal to 0. It's a restriction of fractions. And I solve for x. So x ends up being not equal to 4. Therefore, x has an excluded value of 4 at its domain. So the domain goes from negative infinity to 4, not included, skipping it, union 4 not included, to positive infinite. And the vertical asymptote is a dashed line at x is equal to 4. Step number 2, for the same function that was f of x is equal to 3 over 2x plus 8. Now I'm going to determine the horizontal asymptote and the range. Remember that the horizontal asymptote and the range are directly related. So, in order to determine the horizontal asymptote, abbreviated as HA, I'm going to compare the degrees of the numerator and the denominator and choose the case. I remember that I have 3 cases. In this particular function, notice that there's no variable, x variable, in the numerator. So the degree of that variable that is not there is 0. Therefore, I have case A, where the horizontal asymptote is at y equals 0 or the x-axis, because the degree of the numerator is smaller than the degree of the denominator. Remember that we stated that the degree of the upper part was 0, and the degree of the denominator, since it's not written there, it's a 1. So 0 is smaller than 1. That means that my horizontal asymptote is at y is equal to 0 or exactly at the x-axis. So, the horizontal asymptote is at the line y is equal to 0, crossing the y-axis at 0. And the range, remember that the horizontal asymptote is an excluded value for the range, goes from negative infinity to 0. Not included, I skip it with the union sign, and then retake it from 0 to positive infinite. So on the graph, the vertical and the horizontal asymptote are going to look as follows. The vertical asymptote, which was x is equal to 4, is a vertical dashed line passing through the x-axis at the value of 4. And the horizontal asymptote, which was y is equal to 0, is exactly at the x-axis, or cutting the y-axis at exactly 0. So to continue with the example, now in step number 3, I am going to find the intercepts. Remember that in order to find the x-intercept, I have to solve for x at the numerator. In this particular case, since there's no variable to solve for, there is no x-intercept. Be careful. I do not write x-intercept 0. That would be at the origin. There is no x-intercept, so it is none. It has no x-intercept. Then, for the y-intercept, I evaluate the function with a 0. So f of 0 is equal to 3 over 2 times 0 minus 8. That gives me the value of 3 over negative 8. So the y-intercept is at the coordinate 0, minus 3 over 8. Remember that this is the point where the graph is going to be touching the y-axis. So looking at the asymptotes and the intercepts on the graph, I have my vertical asymptote. I don't know why I wrote 0 there. It's 4. Vertical asymptote at x is equal to 4. This is a vertical asymptote. The horizontal asymptote at y equals 0, dashed line over the x-axis, exactly at the x-axis. And then I have no x-intercept, but I do have the y-intercept at the point 0, 3/8. There's no x-intercept because the graph has the horizontal asymptote exactly at the x-axis. So the graph will never touch, cross, or intersect the x-axis. That's why I have no x-intercept. Pay attention to those details. Okay, so continuing with this one, I go over to step number 4, which is find the key points. Remember that for doing that, I am going to choose 1 or 2 values of x before and after the vertical asymptote. I'm going to use a table of values for the chosen values. So my vertical asymptote was at 4. So I go 2 before, which is 3 and 2, and then 2 values after, 5 and 6. I choose those points, but always taking reference in the vertical asymptote. I substitute these values that I chose in the function, and I get the complete coordinate. Okay, so if I plug in, I get these values. Step number 5. Once that I have the values and everything, I'm going to sketch the graph and state all the elements. So I have my y-intercept, I have my horizontal asymptote, my vertical asymptote, and the points that I got in the table of values. 2 positive, minus 3/4, which is right here. Then 3 positive, it was minus 3/2, which is here, the y-intercept. And then I have 5, 3,2, which is this one, and then 6, 3/4, which is this one. I join my dots, remembering that the graph is a curved line approaching the asymptotes in both directions, passing through the points that I found. And the basic elements are that the domain, remember that the domain is horizontally from -infinity all the way to the vertical asymptote, skipping it and continuing to +infinity. Therefore, this is my domain. I forgot to write here vertical asymptote. I'm sorry. Let me write it down. The vertical asymptote is x is equal to 4. The range, remember that is considered from bottom to top. So I go from -infinity to 0. I skip the 0 and continue to +infinity. That's why I have these in my range. The horizontal asymptote would be at y is equal to 0 or the x-axis. I didn't have any x-intercepts. My y-intercept was the coordinate 0, minus 3/8. And the key points are the ones that I got in the table of values. Please remember to notice that if you have your horizontal asymptote at the x-axis, you will normally not have an x-intercept. There are exceptions that we will see later, but normally when the horizontal asymptote is at y is equal to 0, there is not x-intercept. Now, I will please ask you to try and solve these ones. Sketch the graph and determine the domain, the range, the vertical asymptote, the horizontal asymptote, the x and the y intercepts, key points and holes if any. Remember that we're not seeing cases with holes yet, so you don't have to look for those. We will see those ones later for these two functions. Just as a recommendation, remember that try to factor and cancel anything out before you do anything. Check out what's happening in problem number 2. I'll leave you to it, and then I will show you the answers.